All right, I think we're about ready to go. Everyone seems to be refreshed. So first question, how many of you guys know what a PostHog is? Okay. How many people actually do you use PostHog? Okay, nice. We have a couple. So a little bit of a intro. PostHog is a open source product analytics company. We started out just doing product analytics, but now we do a little bit of everything. I kind of call it a product operations sidecar. So we do all the things that you typically shouldn't build internally. So product analytics, feature flagging, experiments, session replay, all the good stuff. One of the things that we built recently in the last 2 years is data warehouse, which is another thing that you probably shouldn't be building yourself, but it will take in all the product analytics data and augment it with data that you bring to us. So this is basically going to cover the evolution of our storage needs on ClickHouse. We've been a long time ClickHouse user, been using ClickHouse for like 5 years now, actually inspired by Sentry using ClickHouse, mainly because of this guy who was at Sentry at the time. But yeah, it's evolved quite a bit. So first of all, to cover some groundwork, what is a data warehouse exactly? I feel like this is a loaded term, but usually it's a place where structured, usually modeled analytics data is stored. You don't usually put logs in there. You put, a table that you've modeled out really well, maybe in a star schema. Historically, that's been like a Vertica, a Greenplum, Citus. Nowadays, ClickHouse. I would definitely consider ClickHouse a warehouse, not a data lake or a lakehouse, but a warehouse. Traditionally, ClickHouse Cloud is changing that. But why? To do science. I mean, like, if you use these are all really fast. The way that I usually think about it is a data warehouse is backed by disk. It's not backed by object store. What is a data lake? Data lake is on the opposite end of the spectrum. First one that I used was Hive. It's data that's usually super raw and unrefined. It's log data. It's unstructured. Usually you're going to run a job over it and try to derive some structure from it. It's stuff that you keep forever and hope that you find value for. Could be traces, anything. These days, you'll probably use Athena, BigQuery, Hive, Spark. These are the tools you're going to hit or use to hit it. Generally, they're not queried for BI. They're not, Robert was talking about speed of click. You want your queries to return in under a second, maybe a minute, I would even say, speed of click. But these, you're talking like a minute to set up the job, and it's going to take a long time to run. So everyone's talking about a lakehouse these days. And what I actually find funny is lakehouse is a relatively new term. That term only came up in 2020. It was coined by the Databricks guys. And it blends the two together. So you can kind of think of like Snowflake, BigQuery, Databricks as this. You can kind of have best of both worlds, where you have very quick query return times with low latency. And you can have unstructured data and structured data in it. You can basically use this as both. ClickHouse has not traditionally fallen under this as much as I would like it to. So these days, you're finding a lot of this data existing in either unstructured, just raw row formats, or things that are columnar and kind of designed for this with speed improvements. Iceberg, Delta Lake, Duck Lake is a really good blog post that came out recently that there is their interpretation of this. And this does get queried directly from BI. And so with that, let's talk about the typical flow for this. So what I was kind of mentioning earlier, you have your your data lake, which is the unstructured data. You have something like a DBT or a Dagster running over this and modeling the data into your lakehouse or your data warehouse, depending on your use case. If you're a real-time analytics company, you're probably doing something like a warehouse. That's a lot of complexity. Most people should probably not do this if they don't have a team that's managing it, because you end up here. If you lived in that world for any period of time, you probably have heard of the modern data stack, which is maybe not so modern. It is so confusing. I would hate to walk into this world without kind of having a background in it, because you'd end up in analysis paralysis. You'd be like, what am I going to use to like just schedule this stuff? How am I going to get it? Like, where am I going to put it into? Am I going to put it in a Druid? I don't know. And we actually see our customers have this problem quite a bit. And so what I usually try to steer people away from is like, don't do this until you absolutely need to have this. Or look at this. This is like, what we're trying to do in general, and I think everyone should do this, is just skip the middle. Use ClickHouse to start out with, and then just use ClickHouse in the end game. And this is kind of our story avoiding that entire middle land. We do not model data. I have never wanted us to model data internally because it's onerous. It actually slows you down quite a bit. So this is the start of our journey. So right now, or rather at this point, this is vanilla ClickHouse, shared nothing architecture. Everything's in disk, classic data warehouse. State of the world, product analytics, you're basically, everything's local, either in an NVMe, and if you're using ClickHouse right now, go change your nodes to use local ephemeral storage. It will save you a tremendous amount of money. They're very durable, actually more durable than EBS, and it's cheap. But yeah, like this is an example of one of our nodes, how many volumes we have. It's a lot. We have petabytes of our own data on disk. For every replica of a shard, that is just one more set of disks to feed. It's really hard to capacity plan, just for our own data, just for our own first party data. Like our event data and our person data is huge. And eventually we want to add more data to that. So like, what do we do? This is an example of how difficult it is. And I'm sure Rob knows all about this, but ClickHouse, when you want to mutate data, loves to use up every bit of disk available. It basically will rewrite every part that is going to be touched. And so this is our weekly song and dance. One of the requirements for us is you have the right to be forgotten in the EU, so GDPR compliance. Also, customers inevitably always emit some amount of data that has credit card information or social security information or API keys to OpenAI. And they're like, please delete this data. And we do this weekly. And so we literally rewrite all of the data that we've ever collected weekly to basically meet compliance. This is a real pain, and it means that we have to over-provision. On top of the amount of storage that we provision just for the data alone, we have to over-provision to allow ClickHouse to do the merges, to copy every part, which is this whole separate problem. So eventually, in one of the clusters in the EU, we ended up with a bunch of small shards. We have 8 shards, 3 replicas. And there's a whole lot of there are a number of reasons to choose that type of topology. When one of the replicas goes down, it's very quick to re-replicate that data because it's a smaller part of the data. The problem is each of the component nodes is smaller. So when a query is executed against one of those replicas, you only have an eighth maybe of the memory that you typically allocate to much larger nodes. If you have a very large customer writing big queries, your options are basically tell them to not, or to double or quadruple the size of those nodes, which is very expensive if you have a bunch of replicas. So we were in the position where we had a very large customer who was writing very large queries, saying, hey, like we need this to execute. And so we had to figure out a way to not triple or double or quadruple the size of the cluster. We ended up with this, which is effectively a poor man's version of separation of storage and compute. This is like our first little dip into a poor man's data lake, or Lakehouse. So what we ended up doing is we took the existing cluster, which is this, the event cluster. We call that the data tier now. And we put in front of it a set of initiators, which we call coordinators, which isn't confusing at all. But basically, these coordinators are effectively stateless. They only have single shard tables, which are relatively small. They're join tables. And so we can spin them up and down really quickly. And this has gotten us pretty far in this topology. So we have not had to increase the size of the data tier. The data tier effectively at this point is a combination of disks and page cache. So all of the queries that go to that are effectively mapping the data, doing the filtering, hitting the page cache most of the time, and then sending that to the initiator to do the rest of the aggregations and sending that back to the customer. Really nice because we have a lot of flexibility around booting these up really quickly based on demand, or we can even set one aside and say, you're a single tenant on a coordinator, you have all of these resources that are dedicated to you, no noisy neighbors for you. Worked out really well. It also gives you the flexibility to have another data tier that is completely independent. So you could have, like, let's say, events table up here and errors down here, and then have those be managed by the team. It has gotten us pretty far. It's still not perfect because you're still managing a fleet of instances that have a fleet of disks. So then we had another requirement come down the pipe that was, we need to build a data warehouse. So eventually on PostHog, on product analytics in general, you end up starting with the company, like we try our ICP, the customer that we're trying to get is YC batch companies, companies that are just starting out the door. They don't have a data stack. They don't have, it's just the 2 founders trying to build a product, right? We're like, hey, we'll handle all the analytics stuff, figure out if you have product market fit. eventually, if they're successful, they end up saying, hey, look, I need to have BI. I need to pull in my Stripe data. I need to understand like how, do these numbers even make sense? So we had a lot of customers that were like, I need to somehow join this other data against my PostHog data. And we were like, please don't take all your data away because then inevitably you churn, for sure, every time. So we wanted to build out this product that effectively gets people to skip over that entire analysis paralysis stage. So we want to be the Django for the modern data stack. We want to come in really hot with very strong opinions to say like, we'll figure out all the actual mechanization of this stuff. You just bring the data and we'll handle the rest. So targeting small teams. The goal for this is we want to delay. We saw companies that were like literally six or seven people looking to hire a data engineer. And it's like, no, you should really focus on your product. You should not be hiring a data engineer. But we wanted to delay that first hire, but be compatible eventually when they inevitably do need a data engineer. And get the value as soon as possible. Like they shouldn't have to hire a team and wait 6 months for a data warehouse to materialize. So what does this mean tangibly? Ben Stancil has a really great blog post. I don't know if you follow this guy. He is the former, I think his Mode he was the maybe Periscope. He was a BI guy, but basically a really great data blog if you want to see the trends in the data world. But he has a really great blog post that basically says anyone who starts a data company, regardless of where it's at, will inevitably end up being BI. And I firmly believe that's true. I think that's true for us. I think it's true for probably Sentry. But everything comes back to product analytics and everything comes back to augmenting the data that you have with other sources of data and visualizing and analyzing it. So that's what we're doing here effectively is we want to enable people to bring their Stripe data into our warehouse without you putting it on our disk. So that's where we are here, which is basically introducing ClickHouse to Parquet. So we had to go to S3. We already had a metadata store, which is effectively a catalog for storing the metadata on the properties that people send us. So you can send us a properties field on any event or person model that basically has anything on it. All we needed to do is build something that looked like a DAG orchestrator. We used temporal for this and create a couple connectors. So we created a couple connectors for Stripe, HubSpot, Zendesk, Postgres. We actually have a couple more now. Let the users define a schema and bring their own data if they want to, and serialize everything in Parquet because Parquet is actually kind of great. It's really good for S3. And this is what it ended up looking like. So we have a query language called HogQL, which is a superset of ClickHouse SQL. And basically what we do to enable this, what allows us to hit S3 data from ClickHouse is you give it this query, which is like, select something from a data warehouse table. It goes to HogQL. It goes to effectively the catalog and says, hey, give me some information about this. It gives you the S3 Parquet locations, columns, and partitions, and it gives you back this S3 cluster table function, which is like one of the best things about ClickHouse. So this allows us to let customers arbitrarily create whatever tables they want on our cluster without like having us host anything about it. And then they can query it at runtime with this. We don't have to do migrations. Like they can do schema evolutions. It just updates the catalog. This has worked really well. And so they can join against all of our data on the data that they bring in S3. Also, I tried to get ChatGPT to make this a better diagram and this is what it thought. So if you want a computer's interpretation of this, a little trippy. Okay, so this is all open source. Real quick to cover it. If you're interested in how we did this, I wouldn't suggest you do it yourself. You should definitely use Iceberg. But basically, the HogQL parser, we use Antler, the transpiler, the VM, temporal, everything is open source. You can check that out online. But what about events? So we've basically tested S3 and we found Parquet to be really fast for large amounts of data. We still have our first-party events in EBS and NVMe. We never delete data. We've been retaining customers' data for 5 years plus. And so we have this huge corpus of data. Most of it is not touched, right? That's a really big problem because it's occupying very valuable space in EBS. Mo traffic, mo replicas. This means for the more traffic we get, for every user that signs up and gives us traffic, we have to spin up more replicas that just replicate that data. And so we're paying for more compute, but we're paying a lot more in storage. Scaling out takes forever. These instances are huge, and it takes over a day to transfer all of that over 100 gigabit connection, which is kind of absurd. It means that we do not have a true elasticity, right? Like we basically have to provision for peaks, for the projected peak demand for the next 24 hours. And it'd be really nice to use spot instances to do some pre-computing. Like if compute got cheap, I would love to throw some stuff. It'd be like pre-warm some caches and maybe do some roll-ups. That'd be great. We can't really do that. So this is where Iceberg comes in. And this is like, it's funny because this is literally our last graph. And this is why I was like, don't do what we did. This is you get all of the benefits. And this, by the way, is just Iceberg. So what Robert showed earlier, you have an Iceberg table, hits ClickHouse or hits Entalia, goes to AWS Glue, says Iceberg table, and it comes back with all of the metadata that ClickHouse needs to execute a query against that. And you're good to go. It just has so much more going on for it. And like around transactions. You get transactions with Iceberg, which is really nice. You get point in time visibility. So you can basically say, I want to view the state of this data at this transaction ID. You definitely can't do that with our setup. So our intention is to move everything over to Iceberg. So we should use Iceberg. The other thing about this is it really makes all of our operations way simpler. We have 2 different cluster topologies right now with different shapes, different shard counts. The goal with all of this is to have one replica. You want one replica in S3. This is like S3 back merge trees with 0 copy replication, except for you can actually reuse what Robert was saying. You can reuse that data in other tools if you want to hit it with Spark. No disk capacity planning. This is like the dream of S3. This is why everyone wants to go there. You don't have to plan out how many disks you need or go to Amazon begging them to bump your EBS quota when you're on fire, which is always fun. Elastic pool of resources pointing to the same data. Using spot instances would be amazing. Multiple query engines on the same time. Like this is, I ripped this from your presentation. This is the dream. It's what everyone wants. When people say Lakehouse, you want literally this. And so this is why I think ClickHouse in particular, like this isn't new. This is Snowflake, this is BigQuery. They're all doing effectively this really quick querying on data that's in blob storage. But Robert was talking about this a little bit. And this is the real secret about ClickHouse that I'm very excited for is typically when you're writing stuff to Iceberg, there's a lot of prior art for writing data to Iceberg. The problem is not getting it in Iceberg, it's getting it in Iceberg and having it available in real time. Because you're basically waiting for these very large Parquet files to sync into S3, become available in the catalog and be queryable. ClickHouse, on the other hand, is like, I'll write that stuff to disk and make it available right now. I don't care. And then it'll just in the background merge. It's what ClickHouse is really good at. And so the dream world is effectively have your events come in, land in this very vanilla replicated merge tree, merge, do its thing, be available immediately, and then have a TTL over to Iceberg, where it's stable. Like the main thing is S3, you do not really want to do merges in S3. You have to rip all the data out and then do your merge and then put it back in. It's not very efficient. If it's relatively stable, kick it over to S3. You don't have to merge it that often. And then it's there for the long term. So this gives you all of the benefits of a data lake with the performance of ClickHouse, but the long-term costs of Iceberg for storage. Yeah, that's basically it. So this was this is a little bit about 3 years ago. We basically had this dream of building this exact product. And at the time we were like, oh, that'll never happen. But because of all of the things that ClickHouse has been able to do and Altinity, we've actually been able to tick almost everything off of this, which is, I don't know, I think amazing. But yeah, basically, if you are interested in this type of problem, this is scratching just the surface of all the problems we have. We want to build a cost-based query optimizer internally because we let people write queries against ClickHouse. If you know anything about ClickHouse, ClickHouse does not, there's an analyzer, but it basically writes or runs the queries as written, which is really scary when you're letting customers write these queries. And so we have to build a cost-based query optimizer. We're building all sorts of tooling. Yeah, talk to me afterwards. There's tons of stuff. Or talk to Ted. Ted's also working with ClickHouse. Thank you so much. Yes. 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 I mean, there's no reason why it couldn't. Especially like, I'm excited for the export partition, and if you could do basically an import partition, I think that'd be really interesting. I don't think I have a use case for that unless there was like a partition that I thought was going to be hot and I wanted it hot and ready. I mean, I don't think it has to though. Like you could move it around wherever you want. If you wanted to. That merge tree, like it basically, hold on. Yeah. Yeah, maybe you're having an incident because someone's like, you've done, we definitely haven't done this. Maybe you've exposed an API and a user is collecting their historical data. And you want that just to be hot. Like you want it to be on disk and not hitting S3. I mean, there's no reason. This is a merge table in ClickHouse. And with this implementation, you could basically pull that partition over here and it would just return out of the recent events table. Yeah. Yeah. Oh, yeah. Hmm. Robert, I think you had a question?
Yeah, so what's the, I'm kind of.
Yeah. It's such a good blog post. Yeah. Yeah. Effectively. Yes.
Do they see it as,
Yeah. We don't tell them. No, we have documentation for HogQL, but it's effectively ClickHouse. Yeah. Yeah. No, we have users. There are very large customers that use us like Tinybird. Yeah. Which is a problem. That's what, like, honestly, one of the biggest use cases for Antalya is putting that workload there because it is so bursty. It really causes problems on our provisioned like clusters for analytics. Yeah. Any other questions? Yes. Yeah, so using multiple query engines, actually, that's a really good question. And this is something that keeps us from moving to Iceberg right now. So one of the key requirements for us for event data for our own, this isn't like if it was logs, it would be different because it's like write once and it's kind of done. You're never going to mutate it. But because we have customer data and they put random stuff in there sometimes by accident, we have to mutate it. We have to delete it. We also have internal, we do a lot of denormalization that changes fields on events, the relationship for performance reasons. So we have to mutate the data. We probably use Spark at this point for that because we would say, hey, as part of our weekly rewriting of all this data, we would spin up a Spark job that rewrites all of the data on a Spark cluster. And for ClickHouse, it really wouldn't care. It would just see the increment on the transaction ID for the Iceberg table and be like, oh, cool. Like all those rows are gone. Neat. So I do, from a internal user's perspective as well, if we have all of our event data in Iceberg, I definitely see users like using Spark to train models on. Like they're not going to use ClickHouse for that. Most people are not building models using ClickHouse. So having a big job that spins up in EMR or something and just like crunches the data, comes up with something, I could see that. What I'm excited about is as soon as you usually put like data in an open format like this, people will just start using it in ways that you don't even predict. So I think it's going to be a platform thing. Yeah, yeah. If basically another great example is if you need two things. If you either have very large joins that ClickHouse just is not going to be able to execute, or you need to write very bespoke code against the data. Like let's say you have like an algorithm that just doesn't fit into SQL very well. You know, you could write yourself a job that will run in Spark and it'll be just better. Ergonomic, I should say. Anyone else? All right, cool. Well, I'll be around.